Hey everybody, today we're going to be going over the Unit 1 test review. So anyway, I meant to get this posted over the weekend, but I ran out of time. So here we go. So let's start off with this figure here. So it's saying, use the figure to name each of the following. A line containing point A. So here's point A. Here are the lines. There's a bunch of different answers for this. We have this line here, and there's a bunch of names for that. We can call it line L. Line L. You could also call it any one of these combinations of 2 points. So you could call it AB with the proper notation, BC, or AC. You could reverse all those. So it could be BA, BC, CA. It doesn't really matter. You also have this line here. That's a different line. That's AE, or EA if you were to reverse it. Okay? All right. Name a plane containing point D. So this is point D. This is the plane. We can call it plane N. That's a tag we have right here. You can also call it a combination of any 3 points that are on the plane that are non-collinear. So you could have any 2 of these and then D. So you could call it plane, let's call it ABD. You could, like I said, you could call it any 3 points that are on the plane but not all collinear. So you could go to BCD, ACD, etc. You just could not call it plane ABC because all 3 are collinear. All right, where does line AE intersect plane N? Well, it intersects plane N at point A. I'm going to zoom in a little more so you can see a little better. Okay, point A. And then name 3 collinear points. Has to be these 3. So A, B, and C. Okay, and that finishes that figure. So now we have these planes here. How many planes are there? Well, there's 3 planes. Plane P, plane O, plane N. So 3 planes. And then are A, B, and C coplanar. So A, B, and D are, A, B, and C are, however, all 4 are not. D is on plane P, and C is in plane P. So, no, they're not. Okay, let's go down here. So this is segment addition postulate right here. And, of course, the phone's ringing. Hold on a second. Okay, there we go. Sorry about that. Anyway, we're going to use the segment addition postulate here. So we're going to say ED plus DF equals EF because we're solving for EF. So ED plus DF equals EF. And we're going to plug these values in. So ED is 1 and 2/10 centimeters. DF is 1 and 9/10 centimeters. And we're solving for EF. So that'd be 3 and 1/10 centimeters. What am I doing with the decimal there? 3 and 1/10 centimeters equals EF. Okay, over here, now you didn't really need to use it there, but it's just good practice. And you'll see why, because here it's a little more valuable. We're looking for AC, which is the length of the entire segment. So again, we're going to say AB plus BC equals AC. And we're going to plug these in. So AB is X, BC is 2X, AC is 2X plus 5. We're going to solve for X. So we're going to get X, actually let's combine these like terms. So it's going to be 2X plus 1X is 3X. So 3X equals 2X plus 5. And then we're going to, oh, what am I doing? This should be a 2X. You ever do that when you're writing and you're talking at the same time and you write what you said? That just happened. So we're going to subtract 2x from both sides. And we're going to have to scroll over here. So 3x take away 2x is 1x. And then there's that 5. So we have x equals 5. Now we're not done though. So we found x, but now we have to find AC. So we're just going to plug that in for AC. So AC is 2x plus 5. So 2 parentheses plus 5. We're going to plug in our x value, which is 5 in this case. Oh, it'd be helpful if you could see that. Okay, and now we're going to multiply those together. We're going to follow our order of operations. So 10 plus 5 is 15. That's it. And there's no unit of measurement here, it looks like. So those are our 2 answers. So x equals 5, and then AC equals 15. All right, so that's the first page. Hopefully that answers any questions you might have on that. Let's go to the back side here. So we start off with some more segment addition postulate stuff. So it tells us that A is between B and T. Let's get that centered here. Here we go. BA is 2 and 9/10 centimeters. AT is 4 and 2/10 centimeters. Draw a diagram. So let's draw a diagram first. So A is between B and T. So I'm not going to draw this to scale. So it is what it is. So B is between A and T. So sorry, A is between B and T. So it's going to spell bat. Okay, so BA is 2 and 9/10 centimeters. AT is 4 and 2/10 centimeters. And we drew a diagram. So that's that. Use segment addition statement to end your diagram to find the length of BT. So we're looking for the length of the whole thing. So this is actually almost identical to for 7, just that they didn't start off with the drawing. You had to make the drawing yourself. So that's kind of really the only difference here. So we're going to use our statement. So BA plus AT equals BT. And now we just plug these values in. So BA is 2 and 9. I'm going to just write it over here so we have more room. 2 and 9/10 centimeters. Plus, and then AT is 4 and 2/10 centimeters. And we're looking for BT. And we just have to add those together. So what's that? 7 and 1/10, I think. Is that right? Yeah, 7 and 1/10 centimeters equals the length of B to T. Cool. All right. Okay, so we have, again, EFG. Write a segment addition statement for the figure above. So the segment addition statement, people might be confused by that. It's just the form that we've been using. Oh, come on. So there you go. So EF plus FG equals EG. So EF plus FG equals EG. And that's it. That's the segment addition statement. If EF is 21, FG is 2x plus 3, and EG is 26, use the segment addition statement to find x. Okay, so we're just going to plug these in. So EF is 21. FG is 2x plus 3. And then EG is 26. And then we just solve this algebraically. So we're going to we're going to combine our like terms. So 21 and 3 will give us 24. And we're going to get rid of our constant first. So we're going to subtract 24 from both sides. And 26 minus 24 would be 2. So 2x equals 2. And divide both sides by our coefficient, which is 2 in this case. X would be equal to 1. Let's see if that works just before we move on. So 2 times 1 is 2. 2 plus 3 is 5. 5 plus 1 is 26. Yep, that works. Find the length of FG. So we're going to plug in our x value for FG. FG is 2x plus 3. 2x plus 3. We're going to plug in our x value, which in this case is 1. And again, we're going to follow our order of operations and do multiplication first. So 2 times 1 is 2. And plus 3 would be 5. So FG is equal to 5. Okay. Next part, we're going to be doing the midpoint. So our midpoint formula is right here. So number 11, M is the midpoint of PQ. If P and Q are these, find M. So we're going to use these. These are our two endpoints, in other words. Endpoint, endpoint. So we're going to use, this is our x1, y1, x2, y2. Now, it doesn't really matter. Honestly, like you could actually have this be your x2, y2, and this could be your x1, y1, but it doesn't matter. You'll get the same answer. So long as the pair is correct. So as long as these stick together as 1s, these 2s, whatever. So let's plug these in. So x1 plus x2, so negative 2 plus 4 over 2, and then 4 plus 1 over 2. Okay, so negative 2 plus 4 is going to be 2 over 2, and then 4 plus 1 is 5 over 2. And let's simplify that, so it's 1 comma 2.5. And that would be, those would be the coordinates of M. M is the midpoint. Here are the endpoints. Sorry, midpoint. C and D, the endpoints. This is the exact same problem, it looks like. Yeah. So let's plug these in. So x1, y1, and then x2, y2. So negative 1 plus 5 over 2, and then negative 4 plus negative 3 over 2. So negative 1 plus 5 is 4 over 2, and negative 4 plus negative 3 is negative 7 over 2. And 4 over 2 is 2, and half of negative 7 is negative 3.5. So those are the coordinates for number 12 for point M. Okay, number 13. I guarantee some people missed the trick on this one. So AC is the line segment, B is the midpoint. They give us the coordinates of A and B. So we're missing C. We're actually missing the endpoint. So this is the mid, and this is the endpoint. So I'm going to remind you guys, this is back when before this happened. This is the problem that gave a lot of people a lot of hard time. So x1 plus x2 over 2. Now that's the value of that's the x value of the midpoint. So we're going to say that is the x value of the midpoint, or x sub mid. So this threw people off before. So let's try it again. So this is our x1. This is our y1. This is our x mid. That's our y mid. And we're going to plug these in. So our x1 is going to be 9. We don't know what our x sub 2 is. And our x mid is negative 1. We're just going to solve here for x sub 2. So First thing we're going to do is multiply both sides by 2. And that'll give us 9 plus x sub 2 equals negative 2. And then we're going to get the x sub 2 by itself, so we're going to subtract 9 from both sides. And that means x sub 2 would be negative 11. Now because this is multiple choice, we know it's going to be b, but let's just do the y, make sure we didn't make a mistake. So y sub 1 plus y sub 2 over 2 equals y sub mid. And that means we're going to have 3 plus y sub 2 over 2 equals 5. We're going to multiply both sides by 2. 3 plus y sub 2 equals 10. And then subtract 3 from both sides. And then y sub 2 would equal 7. And of course, that's exactly what we have. So that worked out okay. All right, cool. So that's the first page. Let's go on to the second. Well, I guess it's technically the third page. So number 14. Yep. So name the vertex on the sides of the given angle. So the vertex would be the common endpoint for the two rays, so that'd be point I. And the sides are going to be the two rays that form said angle, so IH. And let's make sure we use the proper notation. Zoom in here a little bit. And then the other one would be IJ. Okay, name each angle in 4 ways, so we can call it IHG. Actually, that zoom is kind of bothering me. Let me just see if I can fix that real quick. Properties. I'm using a program called what do you call it? OBS. It's free software you can use to record videos and stream and such. So it's actually very useful for these. Anyway, all right, here we go. So that should take care of the autofocus. So angle IHG and then GHI. Also angle 4. We can also use the vertex. We can use the vertex because there are no other angles at the vertex. But honestly, these two methods, the 3 letters in proper order, are, I think, the best way. Also, number 4, it's not like a great way to use a number to label it because oftentimes we use numbers to measure the angle. So, yeah. All right, name all the angles that have V as a vertex. All right, well, there's actually 3 angles here. We have angle LKV, which is, we'll call that one. So, angle LKV. No, that's not. No, what am I doing? LVK, I apologize. LVK. So LVK is 1. Then we have this one over here. Right? So LVM. And then we have the big one, right? Which would be MVK. Now any of these you can reverse the letters and it'll still be the same angle. Okay. All right, so classify each angle. So our choices are acute. Let's see if I can see them all. Acute, right, obtuse, or straight. So this is what we call a straight angle because it's exactly 180 degrees. 90 degrees would be considered a right angle. This is greater than 90, assuming this is drawn to scale. So, and it's less than 180, so we're going to call this obtuse. This is less than 90, so we're going to call that acute. And over here, we have, this would be obtuse because it's greater than 90 but less than 180. This is acute because it's less than 90. All right, so this is a tricky one. I would say it's right, even though we don't have the measurement, but yeah, that's what I'd go with. And then here, I'd call this a straight angle. Okay. I might have to do this video in 2 parts, because I have to stop this so I have time to get down to my bathroom duty, so we'll see. Maybe I can do it quick enough. Let's see. Name each angle relationship. These would be considered to be adjacent because they're next to each other. Okay. They're also going to be complementary because they have to add up to 90. Okay, these are considered vertical because they're formed by intersecting lines and they're non-adjacent angles. These would be considered adjacent, and that's really all we can say about those. And here, this is going to be a linear pair. You could call them adjacent, but that goes without saying because they are a linear pair, so you don't need to. And that finishes that page. Okay, last page. I think we can do it in time. Okay, last page. Here we go. Find the measure of each angle. So these is a linear pair, so I know they're going to equal 180, so b plus 82 equals 180. Actually, I don't know. It's going to be, we're going to be cutting this close. So we're going to subtract 82 from both sides. I might actually make this at the bathroom duty if I feel really, if I'm feeling, let's see what happens down. There's probably too much noise. 98 degrees, there we go. And then here, these are going to be adding up to 90, so 90 minus 53 equals 37 degrees. I did a little quick on that one. These are verticals, so this is going to equal 65 degrees. They're going to be congruent. And then these have to add up to 90, so it's 30 degrees. I'm kind of going fast, but whatever. Find the measure of, oh, zoomed a little too far. Find the measure of DEG if DEF is 155 degrees and GEF is 75. So GEF is 75. The whole thing is 155. We're looking for this one, DEG. So we're going to do this. We're going to say angle DEG. This is the angle addition statement plus angle, oh, so I should say the measure of, sorry. The measure of DEG plus the measure of GEF equals the measure of angle DEF. What that's saying is this angle plus that angle, which is a big angle. So DEG is unknown. GEF is 75. And then the larger angle, DEF, is going to be 155. So we're going to subtract 75 from both sides. I think that's, what, 80? I think that's 80. Can I do math in my head? I hope so. Yep, 80 degrees. So that would be 80 degrees. Cool. All right, down here, find x. So we know these have to add up to 90 because of the notation. So we're going to say x plus 17 plus 55 equals 90. Combine like terms. So that's 72. Yep. And then subtract 72 from both sides. Ooh, forgot the 90. Subtract 72. X would be equal to 18 degrees. And here we know this is a linear pair. It's a straight angle, so they have to add up to 180 degrees. So x plus 17 plus 131 equals 180 degrees. Solve this algebraically. 17 plus 131 is going to be 148 degrees. And we're going to subtract that from both sides. So 180 minus 148 should equal 32 degrees. I hope these are all right. I'm doing these really quickly. Yeah, they're right. That feels confident, right? It'll work out just fine. All right, so here we're looking for distance, and they give us a line segment, so we're going to use the Pythagorean Theorem. You guys love that. So a squared plus b squared equals c squared, so 2 squared plus 3 squared equals c squared. 4 plus 9 equals c squared. 13 equals c squared. Find the square root of both sides. C equals radical 13. We use the distance formula to find the distance between a and b, so our x1, y1. Oh, can you see that? There we go. x2, y2. And we're going to go ahead and plug these in. So x2 is 1 minus negative 2 squared plus, and our y2 is going to be 3 minus negative 1 squared. I'm going to go ahead and get rid of these double negatives here. So I'm going to rewrite this. We're going to have 1 plus 2 squared plus 3 plus 1 squared. And 1 plus 2 is 3. 3 plus 1 is 4. And that's going to be 9 plus 16, which is 25, and that's a perfect square, so it's actually distance is 5. All right. Estimate radical 45. So radical 45 is between radical 36 and radical 49. It's closer to 49 than 36. In fact, I'd say it's about 2/3 the way. So I would say it's about, and this is 6, this is 7, so I'd say it's about 6.7 or 6.6. It's just 6.7. Find the distance between these 2 points. Okay. No problem. We're going to use distance formula. So x2, y2. And that means we're going to have x2 minus x1 squared plus y2 minus y1 squared. And so we're going to have negative 7 minus negative 3. So be careful when you're doing this. It's easy to make a simple mistake on this. 3 minus 5. Hopefully I didn't just jinx myself. This will become plus. We're going to rewrite that. So negative 7 plus 3 squared. And we're going to write that as 3 minus 5 is going to be negative 2. So negative 7 plus 3 is going to be negative 4. And that's going to be negative 2 squared. So negative 4 squared is 16. And negative 2 squared is going to be 4. Radical 20. Now you can simplify that if you want. Radical 20 is going to be 4 and 5. 2 and 2. So you could write this as 2 times 2 times 5, 2 radical 5. Either one of these is fine. 2 radical 5 or radical 20 is totally fine. All right, so that wraps it up. That's the entire review packet. I apologize for going a little too fast there, but I wanted to make sure that I got to everything. If I went too fast or I missed something or you're confused, please let me know. But otherwise, that should prepare you guys to test, which we will be actually taking on Edge Elastic. So it's a little change of plans, but that's okay. And yeah, sounds good. See you guys soon.